All right, y'all, we're looking at the very last section right now of the Topic 11 notes, the very, very end of it. And as I look at this right here, we start off with this picture of a circle overlaid on top of an XY plane. So I want you to go ahead and label the coordinates for both of those points right there. And while you're doing that, I'm going to point out that A right here, that is the center of this circle, and B is a point that is on the circle. Okay, it's a point that is on the actual line that you draw when you draw a circle. So we ask this question: what is R? And it's kind of a funny question because a lot of times when we're dealing with the calculations that we've dealt with in topic 11, R is a specific number that we're going to plug in for some calculations. So when we talk about R, what it is, really, it is the length of this line segment that I just drew right there. Okay, it's the length of that distance in between the center of the circle and a point that is actually on the circle. Okay, but I want you to think about it like this too. When we have the circle drawn on an XY plane like this, we can actually pretty easily figure out we can calculate what R is based on the fact that to get from the center to the outside, you go over 2 units and up 2 units. That's how we got from point A to point B. So if we set it up like that, what we really have is this triangle right here where A to B, that part of it right there, that radius of the circle, that is the hypotenuse of this triangle. And so if we just do a little bit of the Pythagorean theorem, we can find what the length of that is, okay? When we look at a squared plus b squared equals c squared, well, a and b, those are both going to be 2, okay? That's the 2 legs of this triangle. And then c, well, that is our radius. When we think back to our circle, that r is the hypotenuse. So c squared becomes r squared. And y'all can do these calculations. 2 squared plus 2 squared, it's 4 plus 4, it's 8. When we get down to r squared equals 8, we have to take the square root because we want to have r completely by itself here. So the square root of 8, we're going to do a quick exercise in simplifying radicals like we did, I believe it was in either topic 9 or topic 10. Okay, 8 factors out into 2 times 4. And then this 4 can break down even more into 2 times 2. And so we look for the pairs of numbers in here. I see a pair of 2's right there. So we're going to have a 2 on the outside of the radical. And then over here, we've got one lonely little 2 all by himself. So he's going to be left inside the radical. So 2 square root 2, that right there, this number across the bottom, that is the radius of this circle. Okay, it's the radius of this circle, it's the hypotenuse of this triangle. On a lot of the stuff we're going to talk about today, on the practice problems, you are going to need to find the radius of a circle. And it's going to give you some information about that circle. We'll talk about that as we move along. Okay, what we're talking about today is the equation of a circle. And the equation looks like this. This right here is what you need to write down: x minus a squared plus y minus b, whole entire thing squared, equals r squared. Okay, so your questions are going to be, what is a, what is b, what is r? Okay, r you can probably figure out. R is the radius of the circle. Okay, it's the length of that line segment r, in that line segment in between the center of the circle and the edge of the circle. But A and B are going to be the center of the circle. A and B are the x and y coordinates of the center. Okay? So this raises the question again, what is R? When we're looking at this thing, right here, if we don't actually have a picture of this whole entire thing, how do we find R? Okay? What we're doing is we are finding the distance in between the center of the circle and the edge of the circle. So we can use the distance formula. Okay, and you know that the distance formula and the Pythagorean theorem that we just did right here, very, very similar things, right? Like secretly on the down low, distance formula is just the Pythagorean theorem. Okay, it's a Pythagorean theorem with this side of the triangle and that side of the triangle. And we'd be looking for the hypotenuse, which is r. Okay, so that's what it is. R is the distance from the center to a point that's on the circle. Okay, so here in a minute, we're going to talk about 2 different methods to find the radius. Okay, take a look at this right here. Okay, first off, this question is asking, this first example question on the next page, it is asking what is the equation of a circle with this given center and it passes through this given point. Okay, that just means this point right here, that is the edge of your circle. Okay, so here's the deal. The question is asking what is the equation of a circle. Our answer is going to end up looking like this. Okay, our answer is going to end up looking like this. And the three pieces of information that we need to find to complete this puzzle, we need to find A, we need to find B, and we need to figure out what is R squared. Okay, so for finding A and B, it's actually pretty simple because look at what we just wrote it down. We just wrote down this little fact right here that A, B, that is the coordinates of the center of the center of the circle. Okay, look at this problem. It gave us the center of the circle right here. The center is 3, 0. So A and B are 0. Those are just given to us right off the bat. That's A and that's B. Okay, but the problem we run into now is what is R? How can we find this last number, R squared? So method number one, this is my personal preference. We're going to use the distance formula. Okay, all we have to do is plug in these numbers to that big old ugly mess of a square root that is the distance formula. All right, so we subtract the x values, 6 minus 3. We subtract the y values, negative 4 minus 0. And we plug all that in, we simplify it down. And remember, the reason we're simplifying all this down is because we want to make it easier on ourselves. Okay, the more stuff that you have to type into the calculator, the more opportunities you have to have a typo. The more opportunities there are to mess something up on accident. Okay, so if we can simplify stuff down as much as we can, that 3 squared turns into 9, negative 4 squared turns into positive 16. So we got plus 16 right there. It ends up, in this case, actually being the square root of 25, which we, of course, know is 5. So in this case, it turned out to be a whole number. Okay? Sometimes when you do it this way, you simplify things down, you can get a decimal answer. Sometimes you'll leave it like we did here at the beginning. Sometimes you'll leave it in terms of that square root. It just depends on what the problem is asking for. All right? So whatever you do, however you get to this point right here in the distance formula, we end up with the radius equaling 5. That is method number one for finding the radius, and that's the one that I like because it's very consistent. It's just using that formula and plugging in the numbers where they go right here. Method number two is more like what we did at the beginning. Method number two is to draw the points on an actual graph. And if you have graph paper available to you, this is a really great method, especially if you're a particularly visual learner. Okay, this point right here, that's our center, or positive 3, 0. This is the point that's on the edge of the circle, 6, negative 4. And you can count. You can just count over on the graph that it's 3 units this way and 4 units this way. So the radius of the circle is the hypotenuse of this triangle, just like it was at the very beginning. Okay, so all you got to do then is Pythagorean theorem. And look at this. Starting right here, you have exactly the same steps. Square root of 9 plus 16, square root of 25. Either way you do this, you end up with the same answer where the radius is 5. Okay, that's good information. That's helpful information because that is the last piece we need to plug into our equation right here. So when we're plugging in our numbers, A is 3, B is 0, and R is 5. So that means we're going to turn into x minus 3 squared. We're going to turn into y minus 0 squared. And the other side of the equal sign, we're going to have 5 squared. Now, here's a question for you. 5 squared, that can be simplified. Yes, that can turn into 25. Here's another question. If you subtract 0 from y, does that actually do anything to change y? And the answer is no. So we're actually going to drop out this minus 0 part and just make it y squared all by itself. All right, so we end up with x minus 3 squared plus y squared equals 25. That right there is your answer. That is the equation of the circle. Go on now to those next problems. Hoping to get this done in a timely manner, okay? First off, what are the coordinates of the center? What is the radius of the circle for this equation right here? Okay, something I want to point out to you on this problem. On this problem, our center of the circle was positive 3, 0. Okay, so funny thing though, we started off with a coordinate of positive 3, yet when we put it into this equation, it becomes x minus 3. Okay, that all of that happens because our original formula, this original equation up here, has minus signs inside of it. X minus a, y minus b. Okay, that's why we're subtracting right here. So what I'm getting at is whatever is in the equation, whatever plus or minus sign is in those parentheses, it is the opposite of what your coordinates actually are. So with that in mind, we look at this right here, we look at this equation, we see x minus 5. Well, when we're looking for a and b and r, when we're looking for the coordinates of the center, a and b, we're looking for the radius, r, we have to remember that those coordinates are going to be the opposite of the little sign that you see inside the parentheses. So when we see x minus 5, we have to know that a is positive 5. When we see y plus 8, we have to remember to swap it and say that b is negative 8. Okay, now let's talk about the radius. When we talk about the radius of the circle, the other important thing to remember is that this right here is r squared. Okay, that's the key point of all this. It is r squared. This radius is not 36. The radius is the square root of 36. Okay, so when we swap around our value, our a and b values over here, we swap the signs and we take the square root of r squared. That gives us our answer where the center of this circle is positive 5, negative 8, and the radius is 6 units long. All right, going on to this last question. It's asking the exact same thing. What are the coordinates of the center? What is the radius of this circle? Okay, it's asking those two things. Now, we run into a problem here because you can tell this equation here and this equation here do not look alike. Okay, we want two particular things to happen. First off, we want all of our x's and y's on the same side. Let me see if I can better color on that. We want all x's and y's on the same side. Okay, that is the first thing we want. So what we're going to do is I'm going to move, we want all of our x's and y's on the same side. What I'm going to do is I'm going to move this y squared over to the other side. So the question, how do you undo minus y squared? You add y squared to both sides. Okay, so on the right side, all of this business all goes away. We've got x squared plus y squared now, minus 6. Well, the next thing we want to do is all numbers, all constants to the other side. That's the second thing we want to do. So that means this minus 6, it's got to go. You see this up here? We don't have anything outside of parentheses on its own. Any constant numbers that are not directly attached to x and y are all on this side of the equal sign. So that means we need to get rid of this minus 6 because it's not directly attached to x and y. Okay, so we're going to add 6 on both sides. So that gives us x squared plus 9 plus y squared equals 9. Okay, both of these conditions are met. All of our x's and y's are on the left. All of our unattached constants, we don't have anything else being added or subtracted outside of any sets of parentheses on this side. So that means we're good. Okay, so that tells us that we've got 9. That this side of it over here, this 9, that is r squared. So r, remember this, if this is r squared, 9 is not the radius. The radius is going to be the square root of 9. That's this over here. So we know that the radius is going to be 3. Our last part, though, I want you to look at this. Okay, if I take this x squared and I change it into x minus 0 squared, I ask the question, does that change anything? The answer is no. Subtracting 0 doesn't do anything. In the same way, if I took this y squared and turned it into y minus 0 squared, Does that change anything about it? And the answer is no, of course it doesn't. Okay? We just don't have to write anything down. When you're subtracting 0, you don't write that down because it doesn't actually do anything to your numbers. Okay, so the reason I'm pointing this out is because when you look right here, nothing is being added or subtracted from x or y. And if nothing is being subtracted in this equation, if nothing is being subtracted, then that means your coordinates A and B are just 0 and 0. So that means the center of this circle is at 0, 0. All right, there are some Canvas problems that are, they are just exactly like these problems that we just did. Okay, so y'all let me know if you're having trouble. And that is all we've got for this section of notes. Y'all have a good day.